In this tutorial, we're going to use the RGB color sensor, and we're going to set up things a little bit differently because on Tinkercad we don't have this sensor. So right here I have Arduino Uno and I have the color sensor. Now this color sensor has multiple pins. You have S0, S1, S2, S3 and out pin, and on the left we have the voltage, the ground, and three other pins that we're not going to use. So what we need to do is that we need to connect the 4 pins for the S0, 1 and 2 and 3, and we're going to connect the out. The first 4 pins are basically pins that we will use to command the sensor. So we will give the sensor commands and the sensor will give us an output based on that. Now for me, I've connected the S0, S1, S2 and S3 to pin 4, 5, 6 and 7. Now as for the output pin, the one on the right bottom, the output pin, this one has to be connected to a PWM pin. So if we look at the Arduino, we can see that some of these digital pins has a sign next to it. And next to the digital word, we can read PWM, which is upside down in this case. So this PWM will allow us to read the frequency of the pulse. And this is what we want to read from the sensor for the color sensor. And we will use the S0, S1 and S2 and S3 to basically give the sensor some comments. For example, we want to read the red value, and we will pass 0 or 1 for each pin, and it will give us the red value, and so on. So now we will move on to, after we got this connection, we will start building a simple program to just read the frequencies of the red sensor and the red light, the blue light, and the green light. Now, here's the thing. These values do not really reflect the RGB spectrum that we know from 0 to 255. And you will see now that they're not, it will not give us exact values. So the method we will follow is that we will be placing the sensor on whatever target we're trying, for example, the red light, and we will collect some data of the frequencies for every value, the red, green, and blue value. And then we will take that data to a spreadsheet and find the minimum and maximum for each of those values. And that's how we will be able to identify whether this is a red or a green or a blue based by comparing those values to the spectrum of range that we will figure out. Okay, so first we're going to start by defining a few things. So we're going to define the pins we're using. So for the S0 pin, it's on the 4. The S1 is on the 5th pin. S2 is on the 6th pin. And S3 is on the 7th pin. And we will also define the output pin. So sensor out will be our output pin, and that's we connected it to 9. And we will also create some integers that we will store the frequencies in. So for every color, for every light we have, we're going to read the frequency of it and we're going to store it inside these integers. So 1 for red, 1 for green, and 1 for blue. Okay, and now we will set up a few things in for our pins. The first thing we will do is that we will set up the S0, S1, S2, and 3 to be output pins. The reason they are output pins, as I said before, these pins will be used for us to send the sensor comments, specific comments, in order to tell it what do we want to read now. And we will see now later on when we're reading each value of those what comments we will send it. But first we will define them to be output pins. So we have the S0 output. I will copy paste this for the other 3 pins. And as for the sensor out, that's the value we're going to read from. So it's going to be an input pin. So the sensor out is going to be an input pin because we're going to read the value of the frequency from it. Now there's also something that we should set up, which is it's called the frequency scaling, which is one of the commands we will use when I said we're going to output things to S0, S1, S2, and S3 to command the sensor something. This is the first thing we will do. So you don't have to worry about this part because you don't have to worry about what is the frequency scaling. For Arduino, you usually set it to 20%. And to set it to 20%, we output to the S0 to be high and for the S1 to be low. Now, if you want to read more about these, you can read the spec sheet for the sensor we are using. But for now, we're just going to output for S0 the value high and for S1 the value low. So this is basically a command we're giving the sensor to set the frequency scaling to 20%. And we will also begin the serial because we want to read the values to a serial. So we will begin the serial here. Okay, this is all the setup we need to do. Now we will start reading the values inside our loop. So we will start by reading the red frequency. Now to read frequencies, we need to specify to the values of S2 and S3, what do we want? Do we want the red, do we want the blue, or do we want the green? So to be able to read the value of the red, we need to set the S2 and S3 to low. So if we write to S2 low and S3 also low, this is basically telling our sensor that now we want to read the red value. So whatever is on the output pin is going to be the frequency of the red value. This is how we're communicating with our sensor. So now the sensor will basically be showing us the frequency of the red value and we will be reading it. So we will save it to the integer of red frequency that we created before, and we will use a function called pulse in. It is different than what we usually do to read something as digital because we're not just reading low or high, we are reading a value. We're reading the frequency of the pulse. So we will specify the pin of the sensor out and low. And this basically will give us the value of that frequency for the red. After we set up these 2 pins to low and we read the pulse, we will get the frequency of red. So at this point, I'm going to output to the serial, I'm going to print to the serial the value of the red frequency. And we will also output just a space to separate the values. So this is just a simple space. We will add a delay here of 100 milliseconds for just to be able to read the values clearly. Now we will basically do the same thing for the green and the blue. So for the green, before we set S2 and S3 to low, now to read the green, we'll set both of them to high. I have a typo here, so I'm just going to fix that. Okay. So we will set S2 to high and S3 to high as well. You can read these in the specs for the spreadsheet for the spec sheet for the sensor, where they tell us if you output to these pins high and high, you will be reading the green value and so on. So we will do the same thing as we did for the red frequency. We will be reading now the green frequency. you can notice we're basically reading from the same exact pin. So the only difference there is that we send this message to the sensor. And now the sensor is outputting a different value for here. Okay, we'll add the delay as well, just 100 milliseconds. And we will again do the same thing for the blue now. And for the blue, we need to output for S2 to be low and S3 to be high. And then we will get the blue frequency. Okay, we didn't print things here, so let's do the printing. So after the green frequency, we're going to print the green frequency with a space. And after the blue frequency, we're going to print the blue frequency with a space. And we're going also to add the delay 100 milliseconds. We're outputting all the values on the same line, so we're going to output a new line at the end. So here we're going to do serial dot print. Actually, after the blue, we can just do it here. We will output a new line. I will also add a delay of 1 second here, just to get values by 1 second difference for us to be able to read them clearly. And I will connect the microcontroller and run this script. And we're going to open the serial. We can already see we're reading the values. First column R, second column G, and the third column B. Now we will move our sensor to a position where we want to target, which in this case is the red one. Now it has to be placed in a very stable position if we're going to collect the data carefully. So now I'm going to clear these outputs to start collecting data after we put our sensor in a stable position of what we're trying to target. And now we're collecting data that we will then analyze to know how are we going to detect this red color specifically. Now you can immediately notice that the red is much lower than the other two, which makes sense. And we are getting some stable data, so that's good news. So now I'm going to just disconnect the microcontroller to stop the stream of data. I'm going to take this data we're going to copy all of this, and I'm going to use a Google spreadsheet. So I have here a Google spreadsheet, and I'm going to paste the data first. I'm going to split the text to columns. And basically we are going to get the minimum value, the maximum value, and the median and the average. Now this is a simple analysis we're doing, so feel free to play with this analysis and try to find better optimization to calibrate your sensors. But for now, we're going to just do this. So we're going to get the minimum of first the R, the maximum of the R. We're going to get the median as well. I wrote median wrong. And then we will get the average. And we will do the same thing for the G and the B. Okay, so now basically we can test and try. If we want to read the value of R and it's between these two ranges, and the green is here and the blue is here, and we say that this is this red and anything else is not this red. So this is what we're going to test now, and we'll see what happens. So I'm going to copy these to our script just to be able to use them. We're going to close the serial, and in here I will just make comment of this, and we're going to do a simple if condition. So if the red frequency is greater than or equal 479, we can make it 470. Like, again, you can always optimize these to find what's working for you. And the red frequency is less than or equal to 164, no, sorry, 696. So say 700, for example. And the green frequency is greater than or equal to, it's in the one is 1064, so say 1050. You know, actually, we will try first to not use the green and blue, especially because we are trying to detect a red color, a pure, like just a red color. So let's just first test with red. So if we're finding frequency between these two ranges and we say this is red, does it work? Let's find out. So we're going to output that this is red. So if this is satisfied, then this is red. If it is not, say it is not red. Okay, so I'm going to connect the microcontroller again and run this, and let's find out what happens. I'll open the serial. I'll hold the sensor to the red. Okay, it's reading it as red. That's amazing. It is very sensitive to my hand movement, which makes sense because it's reading frequency. But if I'm stable, especially in the orientation of the sensor, like if I shift it to one level higher than the other, it starts becoming inaccurate. So this is the kind of optimization you will do based on your specific case. But if I hold it still, it is reading it as red. If I move anywhere outside, like the white area, it is reading it not red. The green area, not red as well. You can immediately notice that the red value jumped up, like it's in the 800,000. The blue area, it is not red as well. Actually, it is fluctuating as I move my hand. So a better optimization can happen for sure using the three values together. And this is something that you should play around with and figure out what's the best way for you to detect the state you are in, whether you are in the red or you're switching to white or whatever state you're trying to target. And we just did a very simple analysis for the data we collected, and we didn't even collect a lot of data. You might want to collect more data and maybe apply some machine learning, for example, to try to find a learning model that will take the input of the three frequencies and tell you whether it's red, blue, or green, or white, or whatever color you're trying to target. I hope this helps you to achieve a really cool robot that follows the line. And remember what we discussed about state machines, because your algorithm, the best way to design it is by following a state machine. Design your state machine for following the line, where your states is, what am I doing right now? What is the robot doing? What am I seeing? That's the input. Am I seeing red? Then what transition should I do if I'm seeing red? And so on. Good luck on your hackathons, and always remember, we're always there to help.